Okay, it's Maker Advent Day 4, something different today. We're not doing any hardware. It's all software today. So I'm using something called Tinkercad. Tinkercad is an online free resource and it's a very simple CAD, so computer aided design tool that lets you build anything you want really. You can use it with 3D printers, you can use it with laser cutters. It's just a good piece of software. You'll also notice there's no banana for scale, but don't worry, there's a banana for scale. Back to Tinkercad. Okay, we're going to do something pretty simple today. We're just going to make a container, an object that we can 3D print. So I've got two examples here already. I've got a rectangle, which you can see is hollow inside. It's just got a 1mm thick wall around it and a 2mm thick base. There you go. And I've got a star, which follows the same principle, but it's got a slightly thicker surround to it. And what I'm going to do with this next object is show you how to do that with any object, which you can then apply to any object. You can make hollow things to put stuff in. So this red drawer, I could put a microbit in. So if I go to the electronics parts here, go to the boards, there's a microbit. And it's just a bit too small for a microbit, but oh well. Not a problem, I can spin it round. And there you go, it fits now. Perfect. But I can make containers for things. That's the general premise of this today. So let's go to basic shapes. We're going to just start off with a nice simple, what? A cylinder? Something different. We've done a rectangle, we've done a star already for a little test. Let's drag a cylinder into this. And how big is that cylinder? It is 20 by 20. So 20mm by 20mm. Let's change that to 60. There we go. So we've got a 60mm in diameter cylinder. But right now it's just a solid piece. It's just, if we print this out in a 3D printer, it'd be a solid piece of plastic. So let's change that. Let's go to duplicate, which is up here, top left. Yeah, duplicate and repeat. Click on that, and now we have two. Bit useless right now, isn't it? That it's just the same thing. It's just going to have two cylinders less. Well, yes. But we're going to change the diameter of this to be, let's see, it's 60 now. Let's give it a 2mm wall. So let's do it to 58mm. There we go. Let's put it inside. Okay, you can't see anything yet because I've not done anything. It's just inside, isn't it? Let's raise it up by 2mm. I'm using a little cone here, which will move it up and down. I'll click on it again, and I can, there you go. It's like an elevator. But they're not dead center yet, are they? So I could use the cursor keys and the mouse to make this dead center, or I could be a bit savvy and just highlight them both. Click on a line. And just see, there you go. These little black dots control the alignment, so I can have it aligned in the middle, in the center, to bottom left, but right now it's just dead center. But not yet, I need to do this one. There we go. Spot on. Let's highlight them both now. So I've got both cylinders highlighted. The smaller one is slightly raised from the other one, so we get a 2mm base as well. I'm going to click hole. So now it's generated a void inside that cylinder. So if I highlight them both now and go to group, bingo, got a cylinder, which is also poking through the work plane a little bit. So we've got an object. We've got a cylinder. We could use that to store pens, pencils, spare screws, anything really. But how do we print it? Well, for that we need to slice it. So I'm going to export this. I'm going to go to export here. And I'm going to export it as an STL file. And it's now exported Maker Advent Day 4 STL to my downloads folder. So right now, using the power of OBS, I can switch to Prusa Slicer. And in there, I can import the STL file. You can see Maker Advent Day 4. And there it is. So right now it isn't sliced, it's just a bare object. If I go to slice now and hit that, bingo, it has been sliced. So it's using my custom profile for the Tufty 2040. So if you've seen that green badge I made a few months ago now, that had like a really fine print quality to it. So 2 hours 51 minutes to print all of that, which seems a really long time on my Ender 2 Pro. But yeah, we can slice that, print it, and away we go. That's how easy Tinkercad makes it. Let's switch back to Tinkercad so you can see me. There we go. It's just grabbing objects, manipulating their size a little bit, like Inkscape or Illustrator if you've used that. Put them on a work plane, put them all together, join them, cut things out. It's really simple. And the fact that it's free, and you get all these wonderful things to start you off, you haven't got to make it from scratch basically. You're free to imagine what you can build, rather than thinking, how do I build it? Don't get me wrong, you can sit here for hours building stuff. In fact, I'll open up one of my other ones I've built. Where are we? So, this is how boring I am. I collect, not collect, that's even more boring. I have a large stock of plastic boxes for components, like component drawers. And I want to mount them under a table. So under a desk, I should say. So I measured the lip that surrounds the hinge and the top of the box. And I applied it into this L shape here, with a little bevel just cut out so I could slide it in nice and gentle. I then added some wedges. Not the dude from Star Wars, Ewan McGregor's uncle. Just some wedge shapes there and merged them in. I also added some countersunk screw holes to it, which are M4 size if memory serves. So I can export this now as case size, an STL. Go to Prusa. This is where I need to go to Prusa twice because I have to do it for OBS and for this. And I can say import STL. And it's case size number 4, so I've done it a few times this. And there we go. There it is. So it needs some supports to print, obviously, because that 90-degree angle there is just going to get loads of stringing. Easy peasy. So I mentioned that Tufty badge before, that printed. It's actually a Tom's Hardware tutorial I made that for, and to take it to a Liverpool Makefest. So this was originally an SVG file, so a scalable vector graphic that I created in Inkscape based on the mechanical drawings that Pimoroni had put on their website for the Tufty 2040 badge. And I just sat there and painstakingly drew out the plans of that board and then applied it to a 3D print and then made 3 sections to it. So we have the top bit there, which is like the front of the badge. We have the middle, which is slightly thicker. I'll say slightly, it's 3 times thicker actually than the rest. Then that holds the actual board and the LiPo battery. And I wanted it to be slightly thicker to give the battery a nice bit of space to move around, but also to protect it. And then the last bit is the back. There you go. And that printed, it took about 4 hours to print in total, because I was using a very fine preset on the profile on the printer. But yeah, Tinkercad can be used with anything. Just get some SVGs, import them. You can use them to do text. In fact, I'll very quickly show you that. Where is it? Here we go. It's the spooky one I did for Tom's Hardware. So this is a Tom's Hardware logo. And I printed it upside down because I wanted it to squish the bed plate. I might just spin that over. 180 degrees. There we go. That Tom's Hardware logo there is just an SVG. And I imported it into Tinkercad and then just used a tool to extrude the height of the text. And then I stuck a pumpkin in the middle of it because it was for Halloween. So if you're not comfortable with 3D design just yet, go into Inkscape, do some 2D designs, bring it into Tinkercad and then just extrude, so pull the SVGs up into 3D models and mess around with them. Use them as a tracing tool to make a little project based on that. Anyway, I'm waffling on now, so I'm going to call it a day. Anyway, thanks.